Greetings, dear students. I'm Cosmin Verceanu, and together we will try to begin a new lecture in which we will mill again another part using CNC Simulator Pro software. Today, agenda is to mill what we call a heatsink. So we can find this part in electronics to remove the heat, for example, from the transistors, the active components. So the transistors, electronic components, will be bolted on the heatsink, and the heatsink will help dissipate the power as heat to the environment. So we will make this part now. We will try to make it together on CNC Simulator Pro. And as you see here, it involves the G00, the G01, and a drilling CAN cycle G81 command, which is linear drilling cycle. We will go to the CNC simulator, and we need to make sure that we have a CNC milling machine installed on our part. As usual, we need to install a workpiece here. So add part from the registry, and I already have a part with number 7, and if we go to the registry or pressing F2, we will see that workpiece with number 7, and let's see the dimensions. Number 7, this one. So we will add a part with the dimension 70 on X, 150 on Y, and the thickness of 15 millimeters. So it's a rectangular workpiece, let's say like this. So dimensions of work 70, 150, and 15 millimeters. Good. Now that we have the dimensions and we have the part, we can simulate it here. And you will be able to see your part in CNC Simulator Pro. As usual, we need to set the 0. So set the 0 of the workpiece. So we will do this with G92 command, as you already know, and we will write 30, and the thickness, which is 15, of course, because the thickness of the material is 15. So we will be able now to see the 0 point of the machine. And we have made a mistake here. I need to put the Y coordinate. No, otherwise it will not work. There we go. Now we have the workpiece 0 of the machine here in this point in the upper corner. Good. Let us put also a cutting tool. So I will write the T01, M06, and I will upload a flattened mill to the machine, and we begin by milling this part here, this rectangular part, of the workpiece that you see with purple color. So we will mill first this, and then we will make the holes. We will mill this with tool number 1, so we will proceed to use the G00, and we need to go to X30, Y minus 5, and Z minus 5. Minus 7, sorry. So we need to position fast transverse to this point, and then we will use the G01 to mill, to cut the material until we reach all the length of the material. Therefore, because the part has 150, here we need to put a bigger distance than 150. We need to put the Z as well. Minus 7 will be the thickness. We need to start the spindle. We need to set the feed rate. We need to specify the spindle rotation. And here we have the comment. So we will see what we have done. So I'll zoom out a little bit. So let's see together. Now I will fast forward so that this goes faster. So as you see here, this will mill the entire length of our workpiece. Okay? Now we need to mill again. We need to mill again so that this part from here is removed altogether. So that the thickness of the material will be 7 millimeters. 7 millimeters. Good. Now what we need to do is to reposition the cutting tool with, we'll put here the G00 and we'll write Z0. So we will lift the cutting tool first, and then we will position to 40 and Y155 and Z minus 7. So position the workpiece to this point and cut again G01, Y minus 5. This time, because we need to go to the other side, Y minus 5, Z minus 7, we can write it, or the command it's already done here with Z minus 7. So Y minus 7, Z minus Y minus 5, Z minus 7, spindle speed, feed rate, the direction of the spindle, and we will go again to simulate. So let us see in fast forward. So what do you notice here? We go little by little and we mill this workpiece. No, we mill this workpiece so that nothing remained after this. Next, what do we see here? We will follow the same procedure. And we will go to another point. So because here we have left with some material, it is wise that we modify this X. So we put here 35 and let us simulate again. One fast forward. And we shall continue this. So I will copy this and we shall continue this part. So again G00, Z0. Next we will go to another point. So we will go to another point, but in order for the program to be smooth, we need to have a cutting tool with diameter of 10 millimeters, flat end mill, 10 millimeters. And if we notice here by pressing F2, number 1, it's 8 millimeters. So we can edit this and put here the diameter of 10 and say OK. Say OK again. Or we can choose another cutting tool with diameter of 10, as we have many of these. For example, we can choose another one. For example, T4, it's another flat mill with diameter of 10. So T1, T4 is the same. So here we need to modify a little bit. Here we need to modify a little bit the program, and we will go here to 40. Now go to 40 and cut again. Then we will go to 50. We'll go to 50 and cut again to 155 on Y. And let us simulate now and see what happens. So we go on fast forward to see the simulation faster. And we continue to mill until that part is done and it has no material left. So we will copy this again, and you guess it, we need to change again the dimension. So we need to go to 60 now. No, we need to go to 60, and we will write the 60, and here we go to y-7, of course, and one more of these. We need to go to 70. No, go to 70 here, and we will put positive y, no, plus 155. Good. After we do this, we will lift the cutting tool, retreat the cutting tool, and so G00, Z5. Let us simulate, and we should have completed the milling part of the program. The rest of the program will involve only drilling cycle using G81 command. So everything from here should be removed. Okay, seems like I made a mistake here, so here should be 155 positive, and we should be able to have a good program now. Let's see. Simulation with the milling of that surface completed. So at each step we remove some material until all the surface is done. Good. Now that we have the surface finished, we can begin to use the G81 cycle, which is begin the drilling cycle using G81. So we will use the G81, but first we need to change the cutting tool. So we will go again to the cutting tools, and we will need to begin to use a drill, or go to the tools, milling tools, and we can use a drill with 5 millimeters, and we need to upload it into the machine. So I will write here, insert a cursor, T06 M06. So we will have a drill with 5 millimeters. So insert a drill with 5 millimeters diameter. Insert a drill with 5 millimeters diameter and start the drilling part. We will start first the small holes. Drill the small holes of the part. So we will write the G81 command, as this is the drilling cycle, and we will go to x50 y10 and the depth of -15, so this would be the depth of the hole. R1, spindle clockwise, coolant on. Then we will go to drill the hole at coordinates x50 y30. Go and drill to x40 y20. Go and drill x60 y20. So there should be given four holes to the drilling cycle. Let us simulate, and let us put here the program M30, program, and let us simulate right here the part in fast forward. So this part you are familiar with, no? The milling part. We mill that surface. Until we finish milling. Then we will change the cutting tool to a 5 millimeter drill, as you see here, and we have 4 holes given at the coordinates in the program. We will continue this by giving more coordinates. So drill at x50, y60, drill at x50 and y80, drill at x40, y70, and drill at x60, y70. We will have one set of 4 holes. Drill at x50, y110, drill at x50, y130, then x40, y120, and last one x60, 120. So there should be another two set of holes besides this one. Let us simulate. Let us watch the movie again with the simulation. So change the cutting tool, make the 4 holes for the first set of 4 holes, make the second 4 set of 4 holes, make the third hole 4 holes. Good. Now that we have made the 3 sets, we need to change again the cutting tool to a bigger drill. Change to a bigger diameter drill. So we will use the T5, which is a drill with 10 millimeters, M06. So diameter, using, I made some mistake here, to a bigger diameter drill, which is 10 millimeters, with 5 millimeter drill. So let us see, we change again the cutting tool and we will begin a drilling cycle. No? So again G81. We need to finish this with G80 here and begin another one with G81. This time we will have other coordinates, x 12.5, y 15, z minus 15, R1, M03, spindle rotation, made a mistake here, R1, M03, M08, start the coordinate. So this is the first hole, make the hole at these coordinates, x 12.5, y 15, with the depth of 15. And next we make 2 more holes with the coordinates 12.5, 12.5 on x and y75. So this is the second hole. No, so I write here second hole and make the third hole. Third hole with coordinates x 12.5, y 125. So we will simulate again, and I'll put this again on fast forward. And with this I complete my program, which has milling and drilling cycles, 1 milling cycle and 2 drilling cycles. In this program, as you see here, we have used 3 different cutting tools. One end mill, this one that is running now, with 10 millimeters, flat end mill with 10 millimeters diameter, and 2 drills, one with 5 millimeters, which makes this set of holes, and another 2 set of holes. So 3 different set of holes, and another one with 10 millimeters, which will make these 3 holes. With this we end this program. I invite you to run this, to type this program on your laptop, on your machine, and give it a try so that you will also produce the part that we have discussed here using the milling and two drilling cycles. Let us remember the commands that we have used: G00, fast forward, fast transverse, G01, cutting command. Then we have used the commands G81 and end of drilling cycle G80. With this, I thank you for your patience to watch this video, and you will also have the chance to run the program on your computers, and it should give the same result. Thank you. If you have any questions, please address them on our mutual WeChat group. Bye bye.